So in this video, let's have a look at profiling this Fibonacci calculator. So just in case you don't know what the Fibonacci sequence is, basically it's a set of numbers where in the sequence, each number is the sum of the previous two numbers. So if we take this one, that's the sum of these two. If we take this one, that's the sum of these two, and so on. This calculator just takes a single number, which is the index into a sequence. So say I passed in 1, 2, 3, 4, 5. Say I passed in the number 6 here, then the return value would be 8. So that's all this calculator does. You pass in a number, it tells you what the value of the nth element in the Fibonacci sequence is. This, however, is a really inefficient implementation. It works, but because it's using recursion, now this might not be immediately obvious how inefficient this is. Okay, it's using recursion and it's calling itself, but actually each time we call calculate, that also then makes two calls. So if you pass in like even a smallish number, like we're going to use 45, you'll be surprised by how many times this method gets called. So this is the example we're going to use for profiling this. So how do we start? So we've seen at the top, we've got this play button and we've got a debug button. So we've used that a lot so far in this course. If you do this drop down, we can see this area called profile, and profile with expands out to show a bunch of options. The option that's here is just the last one you did. So if I profile with something else, then in this drop down, that's something else. Like for example, timeline would be here instead. You can also, I won't demo this, but you can profile a running process. So basically when you click on that, you get a dialog appearing with a list of all your processes. So you've got all these default options, and we'll talk about the memory ones in the next video. And we'll talk about these in this video. And you can click on them directly, or you can do edit configurations. And then you can click on them and just change the settings. And before we start profiling this, I just want to talk through some of these options because they're quite worth knowing. So for example, checked here is collect profiling data from the start. So as soon as you start profiling, it'll start collecting data. I can uncheck that, and then I've got a button to actually start profiling, because you might find that when you run your application, there's a few UI steps you've got to do before you hit the area that you want to profile. So you might not want to do it from the very start. You've also got this control profiling via API. Now this is really cool. From code, you can trigger, now is when I want to start profiling or take a snapshot and that kind of thing. And that applies to the memory stuff as well, not just the performance profiling. And there's a few other options like profile child processes, different types of time measurement. So like wall time is basically the name comes from a clock being on a wall, but it applies to a stopwatch on your wrist or that kind of thing. It's basically actual time as time passes, where things like thread time is time within a particular thread. So it's not just as time passes by. Obviously, wall time is a very high resolution timer, but it is as time passes by. So all of these works slightly differently, and because this is the kind of thing that you don't do very often, and then at least for me I have to go and remind myself when I do have to do it. Whilst I'm talking through this, I'm also going to reference the documentation so you can see where to look for a reference. So again, going back to this, and again, it's very good documentation. They've done a really good job. If you go to the profile applications page and scroll down, there's this table here which talks about these different profiles. So timeline is basically collecting temporal, so that just means related to time, data about threads, application events and multi-threaded things. It does mention that on Windows it's using ETW, so event tracing for Windows, and it does require this service running. So this is a separate process and it requires administration privileges. That's not required for Mac and Linux. It's a bit weird here because it says recommended for most use cases against timeline, but sampling also says recommended for most use cases. So that's a bit confusing, I think. But I do get the impression that you'd probably start with timeline unless you wanted something more specific. The sampling is more about accurate time measurement. So if you're measuring time within different method calls, note that it does say that the number of calls is not measured. If you do want the number of calls, and in our Fibonacci example, that's actually quite useful. Then if I scroll down, we've got this tracing, where that's kind of the other way around. So that's more accurate call count measurement, but the time might not be accurate because of the profiling overhead. Now this does take a lot longer, as we'll see in the demo. And there's also line by line, which is Windows only, and it does it on a line by line basis. I can't see this being required very often because you probably get what you need from the other ones. So that's enough looking at the documentation. Let's actually do a profile. Cancel that. And I'm going to start from here and I'm going to say profile with. So I'm going to do timeline. And when we run this, we can say it's launching our project. And this has actually popped it up in another window where normally if I was running Rider, it embeds it, but now it's a separate console window. If I choose, so we don't want that one, that's the next video, demonstrate CPU profiling, enter. Then it's calculating Fibonacci. So this will take a few seconds. So I didn't mention this, but if we bob over to the code and go to program, then I'm calling 45 on that. So that's now finished. That's the 45th value. And then if I exit that, now we can see that this has got a percentage down here whilst it's sorting out the snapshot. Let's let that finish. Okay, so that didn't take long. That took a few seconds. We can see that the process has been crossed out because it's finished. And we've got our snapshots here. So this could be a list, but we've only got one at the moment. And this is the first time we've seen this window. So this is .trace. And again, to have this, you would need the plugin installed, which as long as you've got .NET Ultimate or the All Products pack, when you installed Rider, it would have been bundled in. I can now drill in on the snapshot by double clicking. I can also right click and say open in standalone .trace. So that's the desktop application we saw. But I'm just going to double click to open it in Rider. And we have this. So let's just drag this up a bit so we can see more. So we have a call tree here, which we'll talk about in a sec. We've got a list of hotspots, which is sorted by the percentage of time. We've also got this flame graph view. If I click on here, we can see kind of like a heat map kind of thing, I guess. And you can see that our Fibonacci stuff is a different color. Everything else is gray except for these. You can also right click within this and say scope to this. So rather than showing everything, it's going to drill down within that scope. If I close the flame graph, then this is being filtered down as well. And we can see along the top here, we've got a list of filters and we can see my scope to this is one of the filters. So I could cross this out if I wanted to remove that. I can also filter by subsystem, so like user code, system code, link, file IO, and that kind of thing. I can filter by events, so like just-in-time compilation, memory allocation. I can filter by thread state. I can filter by an actual thread, and then there's the call tree. On the right-hand side, where there's these hotspots, there's a few filters here as well. So we can search. We've also got this, which is follow selection. So this is a toggle option. And by clicking this, then as I click here, then it shows the hotspots under that selection. If I have this unselected, then it's showing whatever the scope is. So do you remember we right clicked and said scope to this? You've also got this, which is hide system functions. So if I uncheck this, we've got system functions. If I tick this, then those are hidden. So if I expand out calculate, which we can see because when we went to the flame graph, remember we scoped to this just to narrow the scope a bit. So if I toggle flame graph, and then hotspots is just toggling this right hand side. So if I see here, we can see that a lot of our time is spent in calculate. And without even looking at the code and only looking at this, we can see there's recursion going on. So we can click here and expand, and we can see this is just calling itself lots of times. So without even looking at the code, we can see this. Now, obviously, our code is very simple, so we could look at the code and see that. But imagine a big application where you've got some recursion quite deep in the code, which you don't know where it's happening. Or maybe not just recursion, but some performance issue. You can see how this will take you straight to where the problem is. Because one of the main goals is finding that method that's causing issues so you can investigate and improve it. And this will help you find that method. You've also got this backtraces button, which is kind of like a reverse call stack. If I click on this, then it's not that clear. So if I turn it off, and then if I go further down the call stack and I right click and say scope to this, and then I show backtraces, you can see it's kind of the reverse. Now you can see this being really useful if you've got a method that's called by lots of things. So you can actually see the tree of what's calling into that method. So in this case, we can see straight away we've got recursion. We can right click and say jump to source or press F4. it takes you to the code and we can look at it and see where the problem is. And as I say, this is a very simple example, a very simple code base, but it could be quite a large code base, and this can take you straight to that bit which is causing the problem. But as I mentioned earlier, looking at this, it might not be completely obvious how many calls it's making to this calculate. So what we're going to do is I'm going to go here and do profile with, and this time choose tracing. Because if you remember from the documentation I showed, tracing does method counts. So if I click on this, this does take a lot longer. So let's do CPU profiling, and I'm going to go away because this is going to take about 3 minutes. So I'm going to go and get a coffee. But when we come back, it's going to be quite surprising by how many calls are made to this calculate method. Right, I'm now back with coffee in hand, and this is now finished, and the timer says 3 minutes. It's only just finished. So if I press enter to exit that, and we now have a trace profile. If I double click on this and then make this a bit bigger, then it's a similar kind of view, but we can see we've got the number of calls now. If I go to the flame graph and I'm just going to right click and say scope to this and then close the flame graph. So let's have a look at this. We've got 1 call. Expand this. 2 calls, 4 calls, 8 calls. So this is power of 2 increment. 16, 32. So following in between these 2 lines, we can see we very quickly get to millions of calls. So you can imagine a developer creating this method thinking, oh, it's just doing a bit of recursion, it's fine, without really understanding that just a few iterations of it actually turns into millions of calls. But thanks to this profiling tool, we can actually look at the numbers and see that massive exponential increase in the number of calls. So let's close this down now. I just want to show you a couple of other things. So if you're in code, well, first of all, we can see here we've got Rider just showing some information, just letting you know that's a recursive call, so it stands out a bit. You can also do from code, once you've got a snapshot, you can do Alt and Enter and go to Navigate to, which we've seen quite a few times in this course. If you've got a performance snapshot open, then you'll see this. If you've not, then you won't see it, but if you have, it's there. And if I click on it now, it won't do anything because I've not got the window open. But if I open it up and go to .trace profiler, and let's just reset my filters so that I've got something selected that isn't this method call. If I then do that again, I'll enter Navigate to, show in performance snapshot, then that's going to jump to that call. So it's kind of a two-way thing. From here, I can go to my code by F4 or right click and say jump to source. Or from code, I can go back to the relevant bit of information within the profiling results. I mentioned earlier about right clicking and saying open in standalone .trace. So if I quickly show that now, then we can view that in the standalone .trace desktop application. But going into this is out of scope of this course because it's a course on Rider. Before we move on to doing memory profiling in the next video, I just want to show that you can profile from tests as well. So I've got this test project. All it's doing is calling our Fibonacci calculator in the same way as we did from program, where we did this. It's just doing the same thing, but from a test. So we've seen in the testing module, you can click here and you've got run debug. We've spoken about run debug and cover, but you've also got profile. And again, if you go to the tests pane, so Alt F8, when you run from here, you can also do profile unit tests. So let's do that. Let's just take this one and profile it. We get this pop-up and we've already spoken about these. So let's just do timeline, which is a quick one. And that's now run. You can see that over here, it's still saying stop. So it's still doing something. So if we give it a bit longer, now this pops up, and in the same way as before, we can see that the process has ended because it's got the strike through, and we've got our snapshot here. So if I double click here, then we've got the same kind of thing. So I can click and drill down and see these calculate method calls. Because I just did a timeline profile, then we've got the times, but we don't have the number of calls in this case, because it was the tracing profile that showed us the number of times calculate was called. So that's certainly enough information to get started with performance profiling in Rider. As I mentioned earlier, to do a deep dive into profiling, that would be a full course, but that should certainly give you enough to get started. In the next video, we're going to look at memory profiling.